Hey, thanks for choosing Student Phase Smart Lecturing. In this video, you would be learning about open loop and closed loop configuration of an op-amp, along with its voltage levels and saturation property. Before learning open loop and closed loop configuration of an op-amp, you need to have a fair understanding about voltage levels and saturation property of op-amps. As soon as we hear the word op-amp or operational amplifier, the first thing that should come to our mind is that it has extremely high gain. Therefore, a small value of input produces very high output. However, we have supply voltage plus VCC and minus VEE, which are used to limit the magnitude of output. Let's assume we apply plus minus 15 volts through supply voltage VCC and VEE, respectively. According to a rule, maximum output voltage is taken as 1 volt less than the supply voltage. In this example, the maximum output voltage is limited to plus minus 14 volts, since the supply voltage is plus minus 15 volts. Once the output reaches their limit, it does not increase further, even if input voltage is increased. This condition of an op-amp is said to be saturated or clipped. The open loop configuration of an op-amp is as shown. The DC supply voltage applied to the op-amp are plus VCC and minus VEE. The output varies linearly between these two. Since it is an open loop condition, the gain is very high. Therefore, output voltage V0 is either at its positive saturation voltage or at its negative saturation voltage. This makes op-amp unable to use for small signal amplification in open loop configuration. Hence, op-amp is generally not used in open loop configuration. However, they are used in few areas to build voltage comparators, zero crossing detectors, etc. The closed loop configuration of an op-amp is as shown. Closed loop configuration is simple. As you can see from the figure, some part of output is fed back to the input. It is considered negative since the output is connected to the inverting input terminal. Feedback helps to control gain, which otherwise drive op-amp into saturation. Resistor, RF, is called feedback resistor. The advantages of negative feedback are: it reduces the gain and makes it controllable. It reduces the possibility of distortion. It increases the bandwidth, that is frequency range. It increases the input resistance, at the same time decreasing the output resistance of an op-amp. It reduces the effect of power supply VCC and VEE on the gain. This concludes the video. Thanks for watching.